right. Well, here we are jumping into a new chapter. We're going to be in chapter 7, section 7.1. We are going to be talking about Gaussian elimination. Like, what the heck is that? Well, let me bring the notes up and I'll walk you through it. A lot of what we've been doing up to this point in chapter 6 was dealing with systems of equations. Now, there is a really cool method that we can use to re-represent all of those systems of equations as just numbers. So that is pretty much where a matrix comes in. A matrix is just a rectangular array of numbers. Okay, each matrix is called an element. And then they have a dimension too. So in other words, they have like a certain amount of columns and a certain amount of rows. So a matrix that has m rows and n columns is said to be of order m by n, or dimension m by n. Okay. And a square matrix of order n is a matrix with n rows and n columns. It's got the same number of rows as it does columns. Okay. I add a little notation here. These are individual elements. The I and the j, they just represent the position that that element is in. So if something is in the ith row and jth column, it's just a, I, j. So in other words, if you want to think about elements that are in a diagonal, it would be a11, a22, a33, so on and so forth. Those are just the main diagonal elements. So here is how we convert everything into from a system of equations into a matrix. So we'll take the coefficients and the constants, and what we'll do is we'll put them into what's called an augmented matrix. So we're going to take the 2, bring it over here, the minus 3 right here, the positive 1 right here, and then the what's on the other side of the equal sign is going to be, there's going to be a line right here in the middle, and then the numbers. And we do that for every single equation. So in the second one, you'll notice there's just an x, so the coefficients are 1. There is 0y, so we put a 0 in that place, and then a minus 3 right here. The 4 goes on the other side of the equal sign. Same thing with the bottom row. Okay. Now, this is called an augmented matrix. We can actually split that into two separate pieces. There's a coefficient matrix, so it's just the numbers that sit in front of those variables. So if you look at this augmented matrix right here, these numbers that are just in the first 3 columns are actually going to be just what our coefficient matrix is. The constant matrix is just made up of the constant terms, so things that don't have variables connected to them. So that's really, in terminology, what it is that we're talking about. Okay, we have an augmented matrix. An augmented matrix is made up of a coefficient matrix and a constant matrix, and that augmented matrix has kind of a line separating those two things. The next thing we need to talk about is row echelon form. Now I'm going to show you a couple ways to do this on your calculator to make life a lot easier for you. I do want to go through just some of the terminology, as well as some of the way that we can do operations within things. A lot of it is just utilizing concepts that we did in chapter 6. The only difference now is that we're not dealing with x's, y's, and z's, or x squareds, or anything like that. It's just numeric. It's just multiplying, dividing, adding, subtracting, and you're just doing it with the numbers. So row echelon form is a matrix that has all of the following conditions satisfied. The first non-zero number in any row is a 1. So every element that is the first number will always be a 1. They're arranged so that the column containing the first non-zero number in any row is to the left of the column containing the first non-zero number of the next row. So what you'll basically see is like a triangular form. Okay, let me switch to my whiteboard here, and I'll show you exactly what I mean by that. So here is an example of a matrix that is in row echelon form. Okay, if I've got a, we'll do a 3 by 4 matrix. We can have like a 1, 3, 4, 7. Then the first item underneath that element under the first row is going to be a 0. And I'll make this a -2 and a 5. I'm just kind of making numbers up here at this point. These next two will actually be zeros. And then this element will be a 1. And I'll make this a 6. Okay. So what you have is that following your little diagonal here, this is actually, all of these are going to be 1s. Okay? Starting from the first element, so A11, which is that first row, first column element. The next one in the diagonal is going to be a 1. The next one beneath that in the diagonal is also going to be a 1. And all of these, you'll see, all of these guys are zeros. So this is in row echelon form. Okay? So in other words, your 1s are the first element that you see. They're going to be the first number in those rows. The zeros are going to be in what looks like a triangular form right there. In fact, that's, I think, some of the terminology we used in Chapter 6. And it's pretty similar to what we're doing here. There's another type, and unfortunately your textbook doesn't get into it, but it actually makes solving these equations or these matrices very, very easy. And there's another form that's called a reduced row echelon form. So what exactly is that? Well, let me go back up here to the very top, and I'm going to erase this and show you something that is in reduced row echelon form. So the row echelon form means you've got a kind of triangular zeros at the bottom, but you can actually keep going when you work through the operations of your matrix and get something that looks like this. So you'll have 1, we'll do this. So we'll do 0, 0, and we're gonna do an augmented matrix here. These will be square. We'll make this a -6. We'll make this a 0, 1, 0, 0, 0, 1. I'll make this a 7, and this is going to be an 8. Okay, makes no difference. So what's a reduced row echelon form? Well, row echelon means that we've got our diagonal. It's going to be the 1s. We've got a triangular 0 pattern on the bottom, but the reduced part of it right here, this is going to come in where we have a triangle also in the upper right. Okay? And the nice thing about that, when we have a triangle here and a triangle here of zeros, what's going to happen is that you can think of these as being variables, and they're going to equal whatever that number is. So what this essentially is saying is x is equal to a -6. This right here would be like a y is equal to a 7, and a z is equal to an 8. Again, these are the coefficients that are on those variables. So that's really what this is saying. And you can actually take your matrix down to reduced row echelon form. I'm actually going to show you how to do all of this in the calculator. Now, I may get a little slack for this or flack for it because doing these operations in the calculator makes life so much easier for you. I'm going to work them out. I'm going to show you how you can work them out, but I'm also going to show you how to do it in the calculator as well. Okay? So we're going to do both. So here is what we're going to do. I'm going to go ahead and take a problem, and we are going to work it into a Well, actually, let's just go back to the PDF. I'm kind of jumping around. So here are some of the elementary row operations that we can do. We can change any rows out. We can swap them out if we want. We can multiply each element in a row by the same constant. We can replace a row with the sum of that row and a multiple of any other row. Okay? So here's a specific example that I give you, and I'm going to walk you through it right now. Okay? Here we're given the matrix 1, 2, 4, 1, 2, 2, 7, 3, 3, 6, 8, negative 1. Okay? So what we're going to do, and again, the book uses a little bit of different notation. I'm going to show you the way that I was taught, and I think is the easiest way to write all these out. So what you're going to do is you have a little arrow going to the next iteration, if you want to call it, of your matrix. And what you can do is above that arrow write down the operations that you're performing from one row to the next. So specifically, what we can do is we notice here we've got a 1, 2, 4. I'm looking at the first element here, okay, the 1. Now row 3 has a 3, so if I want to get rid of this element here in this row, I need to multiply this first row by a negative 3, and then I can add it to row 3. And that's exactly what I tell you here. I'm taking negative 3 times row 1, and I'm adding it to row 3. So what happens? Negative 3 of this, so negative 3 plus 3 is going to be 0. Negative 3 times 2 is going to be negative 6. Plus 6 is also 0. Negative 3 times 4 is a negative 12. Negative 12 plus 8 is going to be a negative 4. Negative 3 times 1 is negative 3. Negative 3 minus 1 is going to be a negative 4. So now that equals, and I put a little star as kind of like the exponent here. That's telling us that it's like our new row 3. The book doesn't use this notation. I'm using that notation. Okay? So what do we have? Row 1 stays the same. Row 2 stays the same. We're just doing that operation on row 3. Okay? Now what? Well, let's go down to the next step. Now I want to get rid of this guy. So to get rid of that, I can multiply the first row times a negative 2 and then add it to row 2 to get a new row 2. So let's go ahead and do that. Negative 2 times 1 is going to be a negative 2. Negative 2 plus 2 is 0. That's exactly what we want, and you can see it right over here. Negative 2 times 2 is negative 4. Negative 4 plus 2 is a negative 2. Negative 2 times 4 is a negative 8. Negative 8 plus 7 is a negative 1. So you get it right there. Negative 2 plus 3 is going to be a positive 1. So that's now what changes. Okay? So now that we've got this in its triangular form, you see the zeros here? That's always the first step. You always want to get the zeros in that triangular form right there when you're dealing with matrices. The next step is actually the really easy one. All you're doing at this point is now multiplying each of these rows that you just reduced down to get rid of these coefficients. You basically want to get these down to just being 1. So the first element in this row that's non-zero, so in this case it's a negative 2, I want that to be a 1. So what do I multiply the negative 2 by in order to get a positive 1? Well, it has to be a negative 1/2. So negative 1/2 times negative 2 is going to be 1. Negative 1/2 times a negative 1 is going to be a positive 1/2. Negative 1/2 times 1 is a negative 1/2. That's where this guy comes in. Okay? Now the same thing applies for the bottom row. So now that we've got the second row with a 1 in the diagonal, we'll move down to the last row. What times a negative 4 will equal 1? That's just a negative 1/4. So negative 1/4 times a negative 4 is going to be 1. Negative 1/4 times a negative 4 for this element here is also a negative 1. Okay? So here is our reduced, or I should say our row echelon form. Now I'm going to show you how to do this in the calculator, starting with the very beginning. Okay, so let me go ahead and switch back to my whiteboard here. And let me zoom in so you can see my calculator when I put it in. Alright, so here's what we're going to do. I don't know if you can see this, how well you can see this, but we'll give it a shot. So first I need to turn it on, and you can see I was already doing some work on it. What we're going to do is we're going to go into second, so hit second matrix. It's right above this x to the -1 button, and you're going to come up with a few different things here. There'll be the names of each of these matrices, some math that you can do with those matrices, and then you can also edit those matrices. And so that's what we're going to do. We're going to click, we're going to go to edit, we're going to hit enter, and the first thing it's going to ask us for is the dimensions. So this is where it's really handy to know how the dimensions work. The first piece right here, the 3, is telling us how many rows there are. So in this case, the example that we have has 3 rows and 4 columns. So it'll be a 3 by 4 matrix. Now I'm going to go in and I'm going to start entering these numbers in. And when you hit the enter button, it'll jump to the next column. So this will be a 2, this will be a 4, and this will be a 1. Okay? The next one, 2, 2, 7, 3, 3, 6, 8. This is going to be 8 and -1. Okay, so now that we're done with that, I'm going to go ahead and hit second matrix again. We'll go to math, scroll all the way down, and what you can do is, if you see, there's a few different operations here. Okay, you can do a lot of this crazy stuff that we just did here in the device. We're going to look at REF. That stands for row echelon form. So hit that. Oop. I was apparently doing that in the element. Let me make sure I go back and do that again. -1, enter, quit. Okay, we got to quit out first. Quit out, matrix, math, scroll down to row echelon form. Okay. Then you have to go back into matrix again. So second matrix, and that one that I just edited, which is matrix A, I'm going to hit that. Close the bracket off. And what you'll see is when I hit enter, it'll pop out a matrix in reduced or in row echelon form. Okay? So these aren't listed as fractions. You'll notice these are decimal notations, and they go out pretty far. They may, in this case, have swapped a few different rows and done things. These may actually look a little different than the solution that you get, and that's totally okay. That's normal. So I do want to point that out to you. They still are equivalent forms. Let me just go back and double check my matrix to make sure I entered everything correctly. I do just want to make sure I'm entering everything in the same way that it was given. 1, 2, 2, 7, 3, and we've got 3, 6, 8, -1. Yep. So that's one way that you can go ahead and get a reduced form. Okay. I'm not sure why they reduced the first row. They might have swapped one and then used kind of fractions from that point on. It's certainly possible. They still are equivalent. That's something to keep in mind. You can have multiple reduced forms of these. They may look a little different. All right, so what I want to do, I want to show you a couple of things here real quick in WebAssign. Okay, so let's go to my browser. Give me just 1 second. All right, so here I am in WebAssign. If I have a question like this, what it's going to do is ask me to submit numbers for the augmented matrix. So what I'm going to do is I'm going to convert this into its augmented form. So the augmented matrix is literally just the coefficients. So 5, -3, 1, and okay, the tab actually dropped it down. This is going to be a 2. This will be 2, -5, 2, and 10. And then let me do the bottom one here. 1, 0, 5, 4. Whoop. Let's see, apparently that tab does not like me. There's the 4. The coefficient matrix is just going to be the portion that is on the other side of the equal sign, the left of the equal sign. So this would just be 5, -3, 1, 2, -5, and 2, 1, 0, whoops, 0, and 5. And then the constant matrix is just going to be 2, 10, and 4. Okay, so if I submit that answer, my solution, there it is. I got them all right. So that's one way to do it. Use elementary row operations to write the matrix in row echelon form. Okay, let me. I showed you an example of this in the notes. I'm not going to go through these 2 examples here. You can go ahead and work on those on your own. I'm going to jump down here to this one, and the reason why is because this actually has something in. It's an augmented matrix, and you can actually get cool solutions from it. I'm going to show you how to do the reduce row echelon form in the device to get this. First, let's actually work it out. I'm just going to do the row echelon form and show you what to do when you get to this point. Okay, so let me switch to my whiteboard. So I don't know how this is going to look because I'm going to try to keep everything as nice and neat as I possibly can on here, but we'll do what we can. And by the way, this is kind of risky, and a lot of people would probably say you probably should have worked these problems out beforehand. I haven't worked these problems out, so this is going to be my first time going through it with you guys. So I just want to put that out there. If you see me make a couple mistakes, hey, it's part of the game. We're all in this process together. We're all learners, and so the way I like to think about it is whatever mistakes you make, that you go ahead and learn from them. Yeah, swig of coffee for this one. All right. Let's do, we got a 3 and 5, which kind of makes it ugly. So what I'm going to do is instead of row 1, a multiple of row 1, and adding it to row 3, I'm actually going to do a multiple of row 2 and add it to row 3. Okay? So we'll do -5 row 2 plus row 3 is equal to my new row 3. Okay? So here's what we get. First row is going to be the same. -7, -16. The augmented matrix and the coefficient matrix, the operations are identical. It's just the line is saying, hey, there's an equal sign there. Just going to let you know that. All right, so -5 times row 2. That means -5 times 1 plus that is going to equal 0. So first off, let's rewrite row 2. -3, -13. Let's rewrite row 2. We're going to get this to a 0. We always start with this, try to get this to a 0. So we'll have a Okay, so minus 5 times that plus that is going to equal 0. That's exactly what we want. Minus 5 times 2 is a minus 10. Minus 10 plus 6 is going to be a minus 4. Okay? Minus 5 times a minus 3 is a 15. 15 plus 1 is 16. Minus 5 times minus 13. Why do they got to put such big numbers in this? Jeez. All right. I'm going to actually just dump this into my calculator. Minus 5 times a minus 13 is equal to 65. 65 plus 35 is 100. Okay. Really? You're going to do this to me? All right, so what do we got here? So now we've got this. Usually, so in the example that I showed in the notes, it worked out where this guy was actually a 0, but usually what we do is we work on the far left side as much as we can, and then we're going to do that one element last to get this a 0. So now that we've got this one a 0, we're going to move up to this one to make that a 0. Okay? So that's really big. Let me try to make it a little smaller so I've got enough space to work with on this entire whiteboard. Okay, that's a little better. Move my arrow here. All right, so what we're going to do, now that we've got our new row 3, we'll take negative 3 row 2 plus row 1, and that's going to equal our new row 2. It doesn't matter what order you do these in, it's totally fine. So minus 3 times that is going to be a minus 3. So first, let's just go ahead and make the rows the same. So the top row is going to stay there. The middle row will be minus 3 plus row 1. That's going to be a 0 here. The bottom row is going to stay the same. We're not going to change that. We just did that one. 100. Okay. The next element, so minus 3 times 2 is going to be a minus 6. Minus 6 plus 7 is a positive 1. Nice. We got that one. We want that to be a 1. That's perfect. So we don't have to work with that to a little bit later. Now we're going to take a look at this guy. Minus 3 times a minus 3 is going to be a positive 9. Positive 9 minus 7 is a positive 2. And now the last one, minus 3 times 13 is a positive 39. 39 minus 16 is 23. Let me just double check that. When you're dealing with multiple steps, it's always best, even if you're unsure of your math, just put it in a device because it will save you so much time down the road. 39 minus 16, 23. Perfect. Just double checking. Doesn't hurt. All right. See if I have enough space here. So now we did that. Let's do... okay, now we want this guy to be a 1. So we'll do 4 times row 2 plus row 3 is equal to our new row 3. Okay. First row comes along for the ride. I'm going to change my spacing here just because I'm running out of space. I want to try to get all of this on the same page, and I'm not sure if I can do that. All right, so now 0 and 0, those aren't going to go anywhere. 4 times that plus that is going to get this down to a 0, which is exactly what we want. So 4 times 1 minus 4, that's a 0. This is going to be a 1 that stays along. These are all going to stay along for the ride, 23. And then these bottom two are going to change. So 4 times 2 is 8. 8 plus 16 is 24. Okay. 4 times 23, let's just do that in the device, is 92. 92 plus 100. Holy cow, that's going to be 192. This is getting big. All right, now we got to work on the diagonals. So this is actually the easy part, because all we do is we multiply it by its reciprocals. So in this case, we're going to multiply the whole top row by a 1/3, the whole bottom row by a 1/24. And what we're going to get is, I'm just going to do this all in one step so you can see it. So 1/3 row 1 is going to equal our new row 1. And then 1/24, wow, row 3 is equal to our new row 3. Okay? So we're going to get 1/7/3 minus 7/3, and then minus 16/3. Okay? This row is already done, so we have that 1 in that diagonal position, which is what we wanted, 23. And then the bottom row, 1/24, all right, of 192. Maybe it's actually something really nice. If it is, I'm going to be really surprised. So 192 divided by 24 is going to equal 8. Wow, I just got really excited. I don't know why. Because I'm a bit weird like that. Okay, so here's how we did it all. You can see this problem. It's working out pretty interestingly. I don't know why I just had this panic moment of, did I copy everything correctly at the very beginning? And I just checked, and yes, I did. So, all right, so here we go. We've got this now down into its reduced echelon form. So what is this really saying? What this is saying is we have, if you think about this in terms of like a system of equations, z, right here, this 1z is equal to 8. So z is equal to 8. That's the first thing that we know. Second, we know that the next equation is y plus 2z is equal to 23, which means that I've got y plus 16 is equal to 23. So y is going to equal 23 minus 16, right? 23 minus 16. I don't know why I'm using a calculator. It's 7. Just gotten in the habit. Anytime I'm dealing with matrices, I just get, it's like kind of overwhelming sometimes. So, all right, so now we got y is equal to 7, z is equal to 8. Let's go ahead and pop those in. So we're going to have x plus 7/3 times 7 minus 7/3 times 8 is equal to minus 16 over 3. So that means that x is going to equal, and I'm going to use the calculator for this one, so give me just a minute. That's going to be 49/3. 8 times 7 is 56, so 49 minus 56 is minus 7/3, and then I'm adding it to both sides. So I'm going to add 7/3 to the other side. So minus 16 plus 7, that's a minus 9/3, which is a minus 3. So our solution should be minus 3, 7, 8. That right there is our answer. So let me go ahead and pop back to WebAssign. It worked out in the end. I'm surprised that there were that many crazy twists and turns along the way. So let me go ahead and punch them in. It's asking x, y, z, so I'm going to go minus 3, comma, 7. I don't know if I can. I'm going to do a space in between just in case, and then 8. And then, I don't need the brackets. Hit enter. Or maybe not. Oh, that saved work. Let me hit submit. And hooray, that's our solution right there. Yes. Oh, that feeling of accomplishment when you work on like a 20-minute math problem and you get down to, oh, it's just so beautiful. So now that's pretty much how you do this. What we just did, what I just did on the whiteboard right there, is pretty much how you do these problems. Now I'm going to show you a new or a different way to do it. And again, this is kind of like the, I don't want everybody to be like, oh, look, it's the cheater way. No, it's not really. This is just using a device instead. Let me go ahead and switch back to the calculator. I'm actually going to put all of this in. Let me zoom in here real quick so I can. Here, I got to bring this down a little bit because I'm like stretching myself to see this. All right. So here's what we have. I'm going to go back in and I'm going to put the entire augmented matrix into this device. Okay. By the way, there's web applications out there that will help you in solving or putting these into row echelon form. Like I said, they might look a little different, but your solution will always come out to be the exact same thing. And so I'm going to show you how to do this in reduced row echelon form. And you're going to see something very interesting happen here. Okay. So if I go to matrix, I'm going to go to edit, hit enter, and it's a 3x4 because we're using an augmented matrix, which means we've got a 3x3 coefficient matrix and a 3x1 constant matrix, which is also a vector, by the way, in case you're curious. So that's other terminology. You don't need to worry about that. So what we have, let me go ahead and punch in the numbers. So we had a 3, a 7, -7, and then the constant on the right-hand side is a -16. This guy is going to be 1. Whoop, hang on. It's going to be 1, 2, -3, and -13. And then this is going to be 5, 6, 1, and 35. Okay. Wow. It's a lot. All right, so quit out. Go back to the home screen. Go to second matrix, math, and then scroll all the way down to I'm not going to do reduced or row echelon form. I'm going to show you reduced row echelon form because something really cool happens. So if I go here, I'm going to enter in my matrix A, close that bracket off. Watch this. Do you see the numbers on the far right-hand side? Do those look a little familiar to you? Well, they really should, because if you go back to what our solution was, there they are. -3, 7, and 8. And that is exactly what we got when we used reduced row echelon form. So here is the thing, okay? And again, I'm trying to make your lives as easy as possible. These diagonals, the 1, 0, 0, -3, the 0, 1, 0, 7, 0, 0, 1, 8, the diagonals right there that are representative by the 1s, those are the coefficients that are connected to the variables x, y, and z respectively in each of those rows. So x, they're saying, what this is basically saying is that x equals -3, y equals 7, z equals 8. And that's it. That's what you get. That's pretty crazy. Now, I believe that some of these solutions for 5, 6, and 7 that are on these questions here, I think that there's excuse me. Whoa, hello. Sorry, I had to mute you. I want to say that one of these has no solution, and then one of them has a dependent solution. In other words, it's going to have one of those C's in there like you had in the last chapter. I don't know what actually shows up in the calculator when you try this, so I'm going to go ahead and try it right now. Because, hey, like, it's a learning experience for all of us while we sit here and fiddle about with our devices. So here's what we're going to do. It's 3 by 4. I'm going to go down the next question. So I'm going to put these coefficients in. 1, 2, -2, 4, 5, 8, -6, 19, 3, 4, -2, 11. All right, so now that we've got that into our device, we're going to quit out. We'll go to Matrix, Math, scroll down to Reduced Row Echelon Form, and I think we might get an error if something does not work. Nope, actually it does. There it is. Oh. Do you notice what happens? Take a look. All right, so look at this real quick. Let me zoom in actually so you can see it even better, even though you probably can see it perfectly fine. So notice what we have here. I've got 1 in the first position, and I've got a 0y, but when I go into the reduced form, it can't get rid of the z in the first row. Same thing with the second row. It can't get rid of that z. So, and notice how the bottom row is nothing but zeros. If you get something like this, what does that mean? Well, let me show you. I have to erase my whiteboard and back out here. Okay, so what does that mean? Let me go ahead and write this down. You get something that looks like this. 1, 0, 2, 3. So this is my line. This is going to be a 0.5, -2, 1, 0, 0, 0, 0, 0. Okay, what this means is this is a dependent solution. So I get 0z is equal to 0. And that's a problem, okay? So what's going to happen is that we get something that's going to look like in terms of C. So the question is, how did we go about solving these previously? Well, the thing that we have to bear in mind, we need to go ahead and let me see here. I'm just refreshing. Not that one. We're going to have the second row, right? The equivalent system. So let's just write this out. So this is the same thing as x 1x plus 0y plus 2z is equal to 3. And I've got, you know what, I needed my spacing here. 1x plus 0y plus 2z is equal to 3. And then we also have that y minus 2z is equal to 0.5. Okay? So we get that this is dependent on z. So what we're going to do is we're going to solve this for y in terms of z. So row 2, we'll have y is equal to 2z plus 1/2. Or 0.5, it doesn't matter. I'm just moving the z to the other side. And then x is equal to, using the first row up here, 3 minus 2z. Okay, so that means our solution is going to be x, which is 3 minus 2c, y, which is 2c plus 1 half, and the last should just be c. So that's our solution. Let me go ahead and punch that into WebAssign and see what it says. I'm really curious, actually. And let's see here. So it was this question, right? Pretty sure it was this question. No, that was the one. Wait a minute. Which question did I put in? I gotta go check my matrix real quick. Matrix 153. Okay, so it's this one. All right, so let me go ahead and punch in what I think the solution is, and I'm crossing my fingers and hoping I get something that's correct, because this will be embarrassing otherwise. 2c plus 0.5, and this will be c. Okay. And fingers crossed, hit submit. Hey, look at that, we got it right. Okay. So again, you can use the reduced row echelon form to really help you identify what happens. Well, since we're here, why not just do the next one? I'll just do all of them. Why not, you know? One of these is going to have no solution. I'm pretty confident in that. I just want to make sure that I just want to see what the calculator gives us, honestly, because I think it could be really interesting. So let's go back and switch to the device. And I got to find my screen here. All right, let's switch back. Okay, so let me clear all this out, and then I'm going to go and punch these numbers in. So I need to be able to see it, though. Give me just 1 second. Got to bring that up. All right, so we'll do a -1, 5, -3, 4, 3, 5, -1, 3, 1, 1, 0. I got a sneaky suspicion this is not going to have a solution. 5. Okay. Alrighty then. Let's go ahead and try the reduced form, see what we get. So we'll go to quit out, second, matrix, math, scroll down to this guy, reduced row echelon form of matrix A. Close it off. And yeah, okay, so here's what happens. When you get no solution, notice the bottom row, how it's 0, 0, 0. What that's saying is 0z, that's hard to say, 0z is equal to 1. And you can't have that. It's the previous example, we had entirely zeros in the bottom row, where 0 equals 0. Obviously, that's true, you know. 0z equals 1. That's basically saying 0 equals 1. So this problem here, when you get something like this, it doesn't make any sense. Therefore, it has to be no solution. Okay? So I'm going to actually go ahead and I'm going to show you what this looks like. Let me just type in no solution. Whoop, hang on. No solution. So one of these guys, relations, wait a minute, hang on, relations. Oh, no solution, maybe that guy. Let's see what happens if I put it in without that. It's probably going to freak out. Oh no, there it is, great. Yeah, there's no solution. Okay, so you can pop that in, just type in no solution, and that'll be it. And while we're here, hey, might as well just do the last one, because we've gone all this way, and it would be a shame if we just didn't do it. Second, matrix, edit A, scroll down, we'll do 2, 2, -4, 2, 2, 3, -5, 2, and 4, 5, negative 9, and positive 4. Okay? So there we have our matrix. We'll quit out. Now we'll go back second matrix, math, scroll down to reduced row echelon form, and I am going to input matrix A, which I just put in, hit enter, and well, looks like we have another dependent solution. So let's go ahead and just do it real quick. I didn't know which one this was going to give us, if it was going to give us an answer or not, but let me zoom out here so you can see what I'm referring to. So what I'm going to do is I'm just going to try to find the solution for it. So we know it's dependent. We know that z is going to be our c value. So what we have is x minus z is equal to 1. And we also have y minus z is equal to 0. Okay? So in this case, let's start with this lowest one. We have y is equal to z, actually. We're solving in terms of z, so that one's a piece of cake. And then the x is going to equal just 1 plus z. Okay? So our solution in this case should be x, 1 plus z, y, which is z, and then z. Actually, I have to do this in terms of c. Sorry, this is the important part. So that should be our solution. Okay? So let's go ahead and pop back to WebAssign. We'll see what we can do here. So I'm going to go ahead and punch those values in as my solutions. 1 plus c, comma, c, comma, c. I'm going to put spaces in between everything because I'm kind of OCD about that. Submit our answer. And hey, look at that. We got it. So I'm doing pretty good on these assignments, guys. Anyway, so that's how you do it. Again, these are going to be, I encourage you to actually do these. So it says, hey, use elementary row operations to write the matrix in row echelon form. I'd encourage you to actually work on these and just to get the hang of it, understand how it physically works, and then you can go back and just double check yourself using the device. Okay, that's all for today, but if anyone has any questions, feel free to shoot me an email, and I will be seeing you all hopefully when things calm down a bit with this coronavirus. Have a good one.